Welcome to the Sang Intermediate Python class. In this class, you will build on what you learned in our beginner Python class. You can build more advanced projects. Let's get started with the concept review from beginner Python. Our goal for intermediate Python is to build a Jackson Pollock turtle project. If you have not seen Jackson Pollock's paintings, they are very abstract and involve many swirled shapes with different colors. We will be replicating this in Python Turtle. Let's look at a demonstration. Here's a demonstration of the Jackson Pollock project that we are going to replicate. As you can see, our background changes color, we draw lines, and we rotate in random directions, which is very similar to how Jackson his art works. Let's learn a little bit about the Turtle library. The Turtle library is just like a little remote control car that can go wherever you tell it to. And something special about it is that it drags and draws a line behind it, just like dragging a paintbrush on a piece of paper. There are several functions that we will learn to control our turtle. First, let's determine what components of the Jackson Pollock project we are going to split this project into. There are 5 things that our turtle will need to do. First, it will have to rotate directions or move around. It will have to change the brush size, change color, change speed, and change shapes. Now let's get started with our Python review. First, let's review comments. Comments are written in your code, but they're pieces of code that the computer ignores. In Python, they can be written using triple quotation marks or a hashtag. When the computer comes across a comment, it will skip the piece of code and it will not be read. Let's do a quick activity. Let's try writing a comment in our code. Then try writing a multi-line comment in code. Comments can be used to describe the purpose of your code or what the line does to provide clarity for other people who are reading your code. Here is an example of a piece of code with comments. As you can see on our first 3 lines, these pieces of writing will be ignored by the computer. And in our last 2 lines, we see a comment describing what the last line does. Now let's review how lists work. Lists are a collection of anything you want. For instance, you could write strings, such as names, or you could write numbers, such as ages or prices. To access an item inside a list, you will type the name of the list, put square brackets, and write the index. In Python, indexing is zero-based, which means the first item in a list is at index 0. To replace an item in a list, you will type the name of the list with square brackets, include an index, and set it equal to a variable. Let's look at this example code. Here we are creating a list called names, and there are 2 elements in our list, Hi and James. We will first access the first element of our list, which we can do by using names with square brackets and a 1. As you can see, this prints out James. Now we will set 0th element of our list to Mark. We do this by typing the name of our list, which is names, put square brackets, put a 0, and set it equal to Mark. If we print out our list again, you will notice that we have both Mark and James in our list, instead of Kai and James. Now let's review how to add elements to our list. In this case, we want to add the word dragon fruit to our list of fruits. Right now, we currently have pineapples and tomatoes inside of our list. However, once we append dragon fruits, our new list will become pineapple, tomato, and dragon fruit. Now let's learn how to remove elements from our list. Here we have yet another list with a name vegetables. Inside you can see we have cucumber and lettuce. Now we want to remove the element cucumber. If we do so, the only element remaining in our list will be lettuce. With all that review from lists done, now let's do a very quick outfit algorithm. For this exercise, we are going to make a list of clothes. Inside this list of clothes, we will have 4 elements: pants, shirt, socks, shoes, or you can add any more that you would like. Now, you will make a variable called temperature, which should be equal to a number. If the temperature is below 50, we are going to add jacket to the list. And if the temperature is greater than or equal to 50, we're going to remove pants and shirt from the list and replace them with shorts and a t-shirt. Feel free to pause this video and take some time to implement this algorithm on your own. Let's review the answer to this activity. For our first exercise, we created a list with the clothing that we normally wear. In this case, we have socks, shoes, pants, and a shirt. We are going to set a temperature. In this case, it's going to be 49 degrees, which is less than 50 degrees. So we are going to wear a jacket because we don't want to freeze in the cold. And our new list will be socks, shoes, pants, shirt, and jacket. Let's try for a different temperature. In this case, our temperature is going to be 51. And 51 is greater than 50, so we will not append jacket to our list. Now let's review the answer to our bonus challenge. In this challenge, we were tasked with removing the pants and shirt element and adding a shorts and t-shirt element if the temperature was greater than or equal to 50 degrees. We can do this very simply by calling our list.remove function twice and our list.append function twice. Let's do a little bit more of list review. Now we're going to learn how to check if an element is inside of a list. So we are going to use the in keyword to check if an element is inside of a list. The in keyword will return a Boolean value, which is true or false, and it can alternatively be used with a for loop to iterate through our list. Here's an example. Here we have a list. Inside of this list, we have many other lists. Notice how we have one that is 157, one that's 234, and so on. Now we want to see if the list 2, 3, and 4 is inside of our original list. If it is, we will print out that the list is present. Otherwise, we will print out that the list is not present. Here's a quick question to think about. Why do we need loops in our Jackson Pollock project? To answer that, let's first learn about what a loop is. There are 2 main types of loops, while loops and for loops. While loops will continue while a condition is true. And this may lead to infinite loops, so recall from Python Beginner of how we can prevent infinite loops. For loops are more structured, and there are 3 types of for loops. The first is using for in range. The syntax for this is for element in range. And we will iterate between 2 numbers, which is from A to B. Our second type is for item in list. This lets us loop through every item in a list without manually putting in a range. Let's do a quick exercise. In this exercise, we will go through a list and check whether a certain element is in it. For instance, with the list potato, tomato, tomato, check whether tomato is in the list. There are two ways to do this. As a challenge, try doing this without looping through the list. Please take a moment and pause this video. Do this activity. Here's the solution to our activity. As you can see, we first create a list with our 3 elements in. Then, we iterate through the list by using for I in plants. And we use a comparison of I is equal to tomato in order to check if an element is in our list. But can we do this with simpler code? Turns out we can. All we need to use is the in keyword. In this code, you can see that we are checking if tomato is in our plants list. With all that in mind, let's do the first step of our Jackson Pollock project. First, we're going to create a list of potential colors and shapes. So this will be 2 separate lists. Colors can be red, green, blue, purple, and shapes will be square, circle, or anything you can think of. Let's look at an example. Here is a sample of what our lists could look like. In these 2 lists, we define colors and shapes. For example, in our first list, colors, we have blue, red, yellow, green, gray. And in our second list for shapes, we have square, arrow, circle, turtle, and triangle, which are all valid shapes for the Python turtle library. Great job! Please take a look at our next video of this Python series, where we will go even further into completing our Jackson Pollock project.